Hello, eighth grade. This is our second PowerPoint lecture on pressure. This time we'll be focusing on air pressure. It's the same deal as on Monday. You should have printed out or jotted down the questions from the handout that was on the second page of your assignment document, and you should be filling out those answers as you're listening to this PowerPoint recording. As I mentioned in the assignment, there will be two places where I'm going to ask you to pause and go back to the assignment document to watch a video. I tried to play the video during this recording, but for some reason it won't record the audio from a video. I don't know if it's a copyright violation of some sort, or I don't know why that happens, but it won't let you record the audio from a video. So unfortunately, you're going to have to pause, go back to the other document, watch the demo, and then come back, but it shouldn't be too difficult. All right, let's get going. All right, so as you know, fluids can exert pressure. We talked about that it's not only solids that can exert pressure, but fluids. We also talked about that fluids include both liquids and gases. So fluids are any material that can easily flow. That's the general definition. And of course, that includes both liquids and gases. And air, of course, is a gas, and air pressure is the type of fluid pressure that we're going to be focusing on today. So what causes fluid pressure? So generally, not just air pressure, but fluid pressure. So particles in a fluid are constantly moving in every direction. And as they move, those particles bump into each other and they bump into every surface that they touch. And as each particle in a fluid collides with a surface, it exerts a force on that surface. So if you look at this illustration, you can see those little fluid particles. And if this were a moving GIF, you would see them bumping into each other. You would see them bumping into the top of the container, the bottom, and the sides. And every time it bumps into any of those sides or into each other, they're exerting a force. And that force is pressure. Okay, how do you calculate fluid pressure? The formula for determining fluid pressure is the same as the one for solid pressure, and you should be very familiar with this formula now that you've completed yesterday's calculation problem. So it's just pressure is the force, and in this case it would be the fluid force divided by the area. So that should be pretty easy for you now. All right, so air pressure. We live at the bottom of 100 kilometers of fluid that surrounds the Earth. This fluid, which we call air, is a mixture of gases that makes up the Earth's atmosphere. These gases press down on everything on Earth's surface, including you, all the time. And air exerts this pressure because it has mass. Each cubic meter of air around you has a mass of about 1 kilogram. And because the force of gravity, which we learned all about in the last unit, pulls down on this mass of air, the air has weight. And the weight of the air is the force that produces air pressure, or sometimes called atmospheric pressure. So you can hold your hand out, palm up, humor me here. Put your hand out as you're listening to this, because I think it'll just make more of an impression on you as you listen to what I'm about to say. So you are actually holding up air, right? You have air on top of your hand. At sea level, air pressure is about 10.13 newtons per centimeter squared. The surface area of your hand is about 100 centimeters squared. So the weight supported by the surface area of your hand is about 1,000 newtons. That's the same weight as that of a large washing machine. That's crazy, right? How could your hand possibly support the weight of a large washing machine and not feel it? Well, the answer is that the weight of the atmosphere does not just press down on your hand, it presses on your hand from every direction, and that pressure balances each other. So balance pressure also explains why the tremendous air pressure pushing on you from all sides does not crush you, right? And we discussed this a little bit on Monday's PowerPoint recording, the whole bit about going up to space, and if you didn't have air pumping into your spacesuit, how the fluids inside your body would be exerting pressure outward and there would be nothing pressing in to balance it out. That's one of the reasons why on Earth we stay balanced, because we have air that's pressing on us in all directions. It's pressing equally on us in all directions, but we also have fluids inside us that are pressing out. So the combination of the fact that it's pressing on us on all sides equally, and we also have fluids inside pressing out, keeps us from getting crushed. Okay, so this is a demo that I was going to try to do in class. It was going to be very exciting because it involves matches, and it's just really cool. I'm excited for you to see it. So this is where I want you to pause the video. You're going to go back to your assignment document, and on the first video link, you're going to click on that, watch it. When you're done, come on back here and unpause and keep going. All right, so go enjoy that video. It's by a channel that calls itself Fun Science Demos, and I don't think we've watched any of his in class yet, but he's really, really good. So enjoy. I think you'll like that one, and then come back. Okay, I hope you enjoyed that video. That was just sort of a general introduction to air pressure, and I think it's a really dramatic introduction to air pressure because sometimes I feel like it's difficult for our brains to sort of really understand the air exerts pressure, but when you see it like that in the bottle and with the egg, it makes it very clear. So now we're going to watch a video that shows what happens when air becomes unbalanced. And when you don't have, the sort of equal amounts of force pressing in and pressing out. And this video is very long, the second video. It's about 14 minutes long. You're welcome to watch the whole thing. It is interesting, but you don't have to. That's optional. I only want you to watch until about minute 250 because that's enough to give you the idea. If you're enjoying it and you want to keep going to see what he does, he basically supersizes it. It's not Science Max. It's a Steve Spangler guy who does it. So but it's the same idea where he first does it sort of on a mini level and then he does it on a really huge level. I don't think he's as good as Science Max. So I personally don't think you have to watch all 14 minutes, but you can if you want to. So now you're going to pause the video again. You're going to go back to the assignment document. And this time you're going to watch the second link. And then once you're done with that, you're going to come back again. Remember, you only have to watch till about 2 minutes and 50 seconds. All right, go enjoy that one and come on back. All right, I hope you liked that video. We are coming to the end of the lecture on air pressure. Just before we finish up, we're going to talk about air pressure and elevation. So if you have ever been up in an airplane or you've been driving up a steep hill or a big mountain, you may have felt your ears popping. And sometimes on a plane, that can be really painful for some people. And this popping that happens has to do with changing air pressure. At higher elevations, there's less air above you, right? So the higher you go, there's just less air because you're higher up. The lower you go, there's just more air above you, right? So try to picture that. And so the higher up you go at higher elevations, you have less air pressure just because there's less air above you, right? You're just going up and that reduces the amount of air that's weighing down on you. As your elevation increases, air pressure decreases. And when the air pressure outside your body changes, the air pressure inside your body adjusts, but sometimes it doesn't adjust quickly enough. It does it a little bit more slowly and it's not balanced the whole time. So there's a moment that the air pressure behind your eardrums is greater than it is in the air outside, and your body releases this pressure with a pop, and that balances the pressure. So when you feel that on an airplane, your body is actually doing what it's supposed to be doing. It's supposed to be balancing out the air pressure on the inside and the outside, but it can be a little bit painful. There are tricks to help speed it along. You can chew gum. Sometimes they have these they almost look like little cups that you can put on your ears to help. You're basically trying to help readjust the air pressure balance quicker than it does naturally. So that's why that happens. All right. In your assignment document, I put some extra demo links. Those are optional. You do not have to watch those. But if you like that Fun Science demo guy, he has a couple other ones that he does. He shows the air pressure with balloons, and it's really interesting. And if you happen to have empty water bottles and balloons in your house, you could even try it out. Tomorrow, we're going to be doing a lab. So you're going to get to test some of this air pressure, some of these air pressure activities at home. And I'm going to give you lots of choices so you can look and see what you have in your house and make it easy for you like that. I hope you guys are all doing well. I still miss you. I did do a Zoom class with my 6th graders today, and that went really well. So I'm hoping to do a Zoom class with you soon. I'm going to see if we can work it out for next week with our lessons. You're doing really well. I'm, really proud of you for getting your work done. I know this has not been easy, and hopefully it'll get easier as we go along. All right, I'll talk to you soon. Bye-bye.